This is America in Space, a weekly news and information program on current events dealing with the space industry. From the Washington News Bureau, here is your host, Rick Potlock.
Welcome to another edition of America in Space. Now that Perseverance has had a successful landing on Mars, what's next? Ken Farley, Perseverance project scientist at Caltech, fills us in on just some of what we can expect and maybe has an answer for us on whether there may have been life on Mars.
3.5 billion years ago, Mars was very similar to Earth in several important ways. It had a substantial atmosphere, it had lakes and rivers on its surface, and it had habitable environments, places where organisms that we know about on Earth today could have thrived. These are the only habitable environments that are known beyond the Earth. And what we're going to do as soon as we get there is to explore the rocks that were deposited in that lake for biosignatures, for evidence of ancient life. Mars 2020 is the first mission which explicitly is seeking the signs of ancient life, and the first mission in which samples will be located and packaged for return to Earth from another planet. And what that means is that the scientists that are presently on the Mars 2020 science team are unlikely to be the ones that analyze the samples. The scientists who will analyze these samples are in school today. They might not even be born yet. And so it's important to understand that Mars 2020 is going to be doing its mission over the course of the next few years, but it is also a serious investment in the future of our science. Mars today is very cold, it's very dry, and it is completely inhospitable on its surface to life as we know it. So the first thing we have to do is we have to check out the rover, make sure everything works, check out the science instruments, calibrate the science instruments, and fly the Ingenuity helicopter. All that's going to take several months, during which science is not the primary focus of the mission. As soon as we're done with that phase, we are ready to go. And what we will do then is explore the geology, which means we will look at the rocks that were deposited in this lake and its surroundings to understand what they tell us about the history of the planet and especially about the history of this habitable environment. And then we will use the very powerful instruments on the rover to look for biosignatures, to look for these leavings of ancient life. And we will collect about 40 samples into the tubes that I just showed. And ultimately, these will be transferred to the follow-on mission that can bring them back. Rocks that are 3.5 billion years old that occur in Western Australia and several other places tell us that life was abundant on Earth 3.5 billion years ago. And they tell us that life at that time was only microbial. There was no complex life at that time. And that's important because if we use Earth as an analogy to what to look for on Mars, we should not be looking for things like fossil teeth or fossil bones or fossil leaves, because life took too long to develop those kind of capabilities to be present in the rocks at Jezero Crater. So we will look for stromatolites, and I particularly like stromatolites because they can be large enough that you can see with your eyes. We can see with the cameras on the rover. That will allow us to locate them in this very large study environment. We also have capabilities on the rover to study the rocks microscopically at a very small patch to look for structures at a much smaller scale that could have been produced by microbial life. And we have the ability to detect and map organic matter. And of course, organic matter is important because all life as we know it is made out of organic matter. People often ask, what is the likelihood that we will find evidence of ancient life? What is the likelihood that life existed on Mars? And of course, we don't know the answer to that. But I'd like to point out that those rocks that are 3.5 billion years old on Earth that have biosignatures in them, that have stromatolites in them, were deposited by microbes in the bottom of shallow lakes and seas. Perseverance rover is about to land in a former lake 3.5 billion years old. This is a tantalizing similarity. It would, of course, be a fabulous scientific discovery to find that life existed beyond Earth. It would also be a very important discovery for humanity in general. We all know that this is one of those questions that people have pondered for a long time. It's also important to understand that even if we don't find evidence of life, that's important too. It's important because it seems that all habitable environments that have been studied in detail are inhabited. If we do a deep exploration of Jezero Crater with the rover and its instruments, and with the samples when they come back to Earth, and we find no evidence of life, we will have shown that in at least one place, there is a habitable environment that is not inhabited. That would be a unique and important scientific discovery if that's what we find. It would tell us something important, that habitability alone is not sufficient, that something else has to be present, some perhaps magic spark that causes life to occur.
That was Ken Farley, Perseverance Project Scientist at Caltech. And that wraps up another edition of America in Space. Reporting from the Washington News Bureau, I'm Rick Potlock.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.